So for those of you who aren't familiar with what the public good instance is, if you've used any of the Sigstore client tools before, like cosign is a popular one, you do your cosign sign, some image, and it says, great, awesome. And then later on, you've got your image and you say cosign verify, and it goes and prints out, hey, yes, I can tell you that this was signed by this person. It's not keeping that all on your local machine, as you probably figured out. And so where is it keeping it? Well, there is an instance that's run by the OpenSSF of Sigstore called the public good instance. And we will battle slide going forward again. So this is kind of like Let's Encrypt if you've ever needed to get an SSL certificate. For those of you who don't remember the bad old days of like 10 years ago or so, 10, maybe 15 years at this point, you need an SSL certificate, and so you had to go to one of these vendors and you had to pay them like 50 or 100 bucks a year to get an SSL certificate, and so no one did it. Let's Encrypt came along and made it easy and cheap to prove, hey, I should get a certificate because I own this domain name. The public good instance is like that for signing code. Instead of having to keep track of all your, like keep a GPG key and figure out how to operate that every time you do a release. I mean, GPG is user-friendly software from the 90s from crypto nerds, so I'm sure you'll figure it out. It's only a little harder than Git, so, so Sigstore makes this a lot better. And lets you leverage your existing identities. So this is kind of awesome, but how does it actually work underneath? Going back to the earlier discussion about security, this is one of those things where we can't show you all the pieces because we want to keep a little bit of space between how it works in the theory, which we're happy to share, and the specific implementation details, like it's this GCP project number, for example. And so, as you probably figured out by that hint, most of this runs on Google Cloud. Some of it runs elsewhere, but most of it runs on Google Cloud, and uses Google Cloud's load balancing, and then a Kubernetes cluster where we run a lot of the actual Sigstore infrastructure, and that's backed up by MySQL databases where the data is actually stored. There's some Redis, and Tuf also uses like a cloud storage bucket. But, okay, there's this set of cloud resources that run. And furthermore, there's actually two of them. The one that you all see and use that we call production. And then there's a staging one as well so that we can test everything out before we go live. So there's actually two copies of all of this. Everyone sees and interacts with one. If you're on the on-call rotation, you interact with and deal with a lot more noise in the staging environment because we want to get it right before we go to production. Probably not surprising, but these are two separate instances, two different Kubernetes clusters, two different MySQL databases, and everything else. And then your next question might be, okay, well, how do you manage all that stuff? Did somebody click around a whole bunch in the GCP console to set all this up? No, that would be crazy. Most of this is set up through Terraform. The best part, which I will get to in a moment, is almost all this setup is actually open source, except for those specific values of use this GCP project, give these people access to it, and so forth. So Terraform sets up the GKE cluster. It sets up the Cloud SQL databases and the load balancers. It sets up GKE key management and the Redis and the monitoring stack and all of those other pieces. So that's repeatable and reviewable. So it's not public because those values are that private stuff, but it is reviewed, and it's, person A proposes a change, person B approves it, and then it rolls out through automation that's driven through GitHub Actions for the most part. So it's not just somebody sitting down and typety type, hope it's right. Oh gosh, we just blew away all the signatures everywhere. And we do run game days to think about, oh, what would happen if this happened or that happened. And then on the Kubernetes side, we use Argo CD to apply Helm charts. And as I was alluding to earlier, most of this is open source. So the Terraform is all in Sigstore scaffolding. So it's GCP specific. If you're thinking, oh, great, now I can just take that and run it on AWS. Not so fast. If someone wants to build that scaffolding for AWS, that would be awesome, but it's currently very GCP specific. The Helm charts are less GCP specific. They're not completely not GCP specific, but those are more easily moved somewhere else. There's some pieces that at least the Sigstore instance uses, like the Cloud SQL proxy, that are a GCP specificism. Stuff that's not open source, that's just straight up in that private instance, the identity and access management, what are the groups that are used to manage all those GCP resources? Maybe that could be open source, but it doesn't really feel like your org is going to have your own stuff. That kind of feels private. And the DNS setup is not open source because if you want to see it, just do DNS queries and you'll find all the records. But stuff like TTLs and it's just not interesting to try to open source it. So that's great. Now you have a little understanding as to what goes into actually running the instance from the machinery side. But how do we know it works? I mentioned earlier there's an on-call rotation. That on-call rotation is staffed by various OpenSSF member organizations. I am going to be on call very shortly for my first time representing Stacklok. But we have folks from Google and folks from Red Hat, and a deep apology, I don't actually remember all the different groups. So I'm going to leave it there, and if you weren't one of those 3 groups, I apologize. But we actually do probes, both from GCP to make sure that all of that mechanism works, and also from GitHub, so that we're checking that the connectivity to Google actually works and that the load balancers and so forth on the, work correctly for the rest of the internet. We also have some availability checks that go through better uptime. You can actually check out that URL, that's public, and you can see that overall we have very good availability. And there's a little screenshot. You can see there were 3 minutes on June 16th, I think, where the uptime probe failed. But other than that, green throughout. And I know that I got started a little early and I got done a little early, so I think maybe we'll have some extra networking time unless people have questions they want to ask, because I think I've got a couple minutes, and so I could answer a question if anyone had one. Oh, the question was how much traffic is there? I actually don't know the answer to that one. It's a lot more in production than in staging, but I don't know. Since it's only the metadata signing parts of things, it's not as intensive as one might fear. What? Yeah, I don't unfortunately know how many requests per second it is. Yes, that would. I might be able to go look that up, but I don't have the throughput numbers off the top of my head.
It would also be good to know how many people verify, because we can sign everything, but if nobody cares and verify it, it's kind of useless.
So I think I'm hearing that people would love to get a little more transparency on the actual traffic numbers for both signatures and for verifications. Personally, also, when I say those two things, it also makes me think how many transactions complete versus abort on the signing side. But I don't know how much of that we do and can publish. But I will. Well, one thing we'd have to worry about, for example, is denial of service attacks. If we tell you how much capacity we have, then that tells you how much gap. Um, but I'm not the sole decider here, so I'm happy to try to get you more of that information, but I don't like making promises I can't keep. So that's why I say maybe. Oh, go ahead.
How many nodes do you have in Europe?
I believe that all the infrastructure is in the US at the moment.
How do you handle GDPR?
I don't know how the public good instance handles GDPR, particularly given that it's all in a Merkle tree. And you actually can't.
Relevant question,
Oh.
how do you handle revocations and deletions? What if someone publishes information on there that wasn't theirs to publish?
The question was, how does Sigstore handle deletions, and what if someone publishes something that they didn't mean to publish? I think the certificate transparency logs are going to be there, and you can't really take them back. Yes, if you have. So there's a, yeah.
But also, if somebody was to make a GDPR claim,
Mm-hmm.
you can shard. We really don't like to do that because we're not being transparent about it. But it is
Yeah.
a possibility.
There's.
Somebody's personal danger.
Okay. It sounds like maybe there are exceptional. Yes, I'm going to repeat that.
Generally, it's not a good idea to put something into a public transparency log.
Yeah. So Luke, who's one of the founders of the Sigstore project, was saying that in general, it's not a good idea to put things in a public transparency log if you don't want them to be there. In the cases of like physical safety dangers, there might be maneuvers we could take, but they're not exercised very often.
I think that the point that was raised was actually more in terms of like, what if I just got all the, like, just got, I don't know, like Pirates of the Caribbean,
Mm-hmm.
and I just threw all of that on
Oh,
Sigstore.
so the question was, what if I took some material that didn't belong to me and stored it in public Sigstore? Well, the answer to that is you don't actually store it in public Sigstore. You'd only store a signature on it in public Sigstore. So you would be storing, I claim at this date and time I had this thing, which might be great evidence against you in a trial, but might not otherwise actually let anyone else get the data. Oh.
I had a question kind of related to yours.
Mm-hmm.
The infrastructures in North America now, are there plans to grow the infrastructure into other GCP regions?
The question was, how difficult would it be to span the Sigstore into multiple GCP regions? So they're in different availability zones, but my experience in general with distributed systems is that when you take a database and you say, oh, I'm going to put it in multiple regions, speed of light starts to bite you real hard on the butt. But I have now used up my time, and so we're going to let people get, or at least they're telling me at the back that I have. So I'm happy to take more questions after.